Hello, good morning everyone. My name is Olajide Tobiloba Samuel. I'm here to present my undergraduate research topic titled Neuroprotective Effect of Aqueous Liver Extracts of Cola acuminata in Scopolamine-induced model of dementia in male Wistar rats. Firstly, I would like to appreciate the organizer of this virtual conference for giving me the opportunity to present my research work. By the way of introduction, dementia is a common progressive clinical disorder that develops slowly over years, and it is associated with older age. Dementia is a major symptom of various neurological disorders, mostly the neurodegenerative diseases. Examples of such are Alzheimer's disease, Parkinson's disease, Huntington's disease, and again we have numerous types of dementia because dementia has been seen to be associated with numerous neurological diseases. We have Alzheimer's disease dementia, we have Lewy body dementia, we have frontotemporal dementia, we have vascular dementia. Those are the four major types of dementia that we have. An estimate of about 55 million people are affected worldwide, and this number is likely to rise to 78 million in 2030, according to WHO. Neurodegeneration of cholinergic neurons that produce acetylcholine that are necessary for memory and learning, are the major hallmark of dementia. And this neuron has been seen to be more seen in the entorhinal cortex and the hippocampus. So, damage to this neuron in this particular part of the brain, in the entorhinal cortex and the hippocampus, are the major hallmark of dementia. However, this disease is currently being managed by cholinesterase inhibitors such as dompezine, galantamine, etc. But the adverse effects associated with the use of this standard drug, coupled with the high cost, have limited their use. So hence, in this research, we try and explore the use of medicinal plants called Cola acuminata to ameliorate induced dementia in rat model. So Cola acuminata, as we all know, probably those in the western part of the world may not know Cola acuminata. It is called the kola nut here in Nigeria, and in this research we try and use the leaf, not the seed. The seed has been researched on, and it has been proven that it can ameliorate induced dementia in rat model. But however, in this research, we explore the use of the leaf, and the aim of this research is to evaluate the neuroprotective roles of aqueous leaf extracts of Cola acuminata in scopolamine-induced model of dementia in male Wistar rats. Our method, the way we did our extraction, that's our method, and the grouping and the biochemical analysis. Firstly, we did the aqueous extraction of the leaf of Cola acuminata, which is the kola nut. It is usually kola nut. Let me explain kola nut. Kola nut is a seed that is usually eaten in the western part of Africa. Mostly in Nigeria, it is eaten by older adults because it has been believed to act as stimulant to the nervous system in general. So We did the aqueous extraction of the leaf of kola nuts and evaporated to dryness to get the extractable matter that was given to the animal. Our grouping, we had 6 groups. 30 Wistar rats was randomly selected to form a 6 group. We have group A, B, C to F, and the group A is the control group. Each group has 5 animals each, and group A is the control group, group B is the negative group, and the C, D, E, and F are the positive group. So in group A, they receive only the vehicle, which is the transporter of the drug. The normal, we use distilled water. Some research can use normal saline, but we use distilled water as the vehicle. So the group B is the negative control. They are the group that received scopolamine. They received it intraperitoneally through injection. The group C, D, and E, and F. The C received standard drug, which is a drug used for managing dementia. And the D, and they were given orally. The dopamine and the extracts were given orally, and they were given along with the scopolamine, which is the chemical that induces dementia. So our group D, E, and F received the extracts in different dosage. The D received 50 mg, E received 100 mg, and the F group received 300 mg. So in our results, we did 2 behavioral tests for this in this research. We did the Morris water maze test and the light and dark box test. And firstly, when we got our animal, we allowed them trained inside the Morris water maze test for 14 weeks before we commenced the administration of the drugs and extracts. So this is the Morris water maze test. This is it. The Morris water maze test is a circular basin filled with water, and the rats, our Wistar rats, is dropped at this portion. They are dropped at this portion, and we try and train them in a way that they will quickly locate this platform. We did that for 14 days, and we also on the last day of the training, we did what we call probe test. In this test, we removed this platform where they usually come and stay when we drop them inside this water, because when we drop them inside this water, they feel agitated and they find their way out of this water to this platform. So on the 14th day, we did what we call probe test. We removed this platform, and we discovered that each rat we drop into this basin, they try and find their way to this platform. So that shows us that they have actually learned what we want them to learn. So the light and dark pulse test was only done after the administration of our drug. It was done on the 7th because our administration was for 7 days. So this light and dark burst test was done on the last day of our administration, prior to the day of sacrifice. So in this, let me explain the light and dark burst. The light and dark burst is a test for short-term memory. It is a test for short-term memory, and the procedure goes like this. We put each of the rats inside a compartment, either the black dark compartment or the light compartment, and we allow them to move freely within the passage between the dark compartment and the light compartment. They move freely. Then after that, we remove them, and we remove each rat. We did it one by one. So we remove the rats and we try and block the entrance with a barricade. We block it with a barricade, and the number of time we now did a recording after we've blocked the entrance. We returned the rats into it, and we did a recording for about 5 minutes, a video recording for about 5 minutes, and the number of time it takes for the animal to actually go to the barricade, the number of time it takes for the animal to actually go to the barricade where we block, for it to move between the light and dark burst. We recorded it, and that is what we call the frequency. That is what we call the frequency. So this graph was gotten. This graph, sorry. Okay. This graph here was gotten from this graph was the result that was gotten from the light and dark burst on the last day of our administration, while this graph up here was gotten from the Morris water maze test. Our result shows that our result shows that for the Morris water maze test, which is this graph, we can see that the number of time it takes for the group B, the scopolamine group, which is the negative group that was induced with dementia and was not given any drug or extracts, we can see that the time taken for the animal to locate the escape platform, which is this platform, was very high. It was very high compared to other treated groups. The one treated with dompezine, group C, the one treated with extracts, which is D, E, and F, at different dosage. We can see that the time taken for the rats to locate the platform in the scopolamine group was higher than that of those group that received the extracts. This shows that the extracts given improved their learning and memory, because they were able to locate the platform so quick than the scopolamine group. Then for the second results, this was for the light and dark burst test. We can see that the number of time it takes for the animal to actually locate the entrance between the light and dark compartment was very, very low for the scopolamine group compared to the treated group. In fact, we can see that the group D here, the group D that received the extracts in 50 milligram per kg, the number of time it takes for it to locate the entrance, the entrance that has been blocked, was higher compared to every other, compared to the scopolamine group, even compared to the standard drug group, that is the Dompezi group, group C. So this shows that this extract actually increased their cognition, and this was to assay for the short-term memory, the light and dark burst. We also did biochemical analysis. We try and measure the activities of acetylcholinesterase, which is a drug, which is an enzyme that breaks down acetylcholine. Acetylcholine is needed for learning and memory in the brain, and these activities of acetylcholinesterase break down acetylcholine. The breakdown of acetylcholine is the major hallmark of dementia, as I've said earlier. So when we did the analysis for the acetylcholinesterase activities, we can see that in scopolamine group, the group B, the activities was so high compared to the treatment group. And we can see that the Dompezi group was low. The scopolamine group, which is the negative group, was high, and those that received the extract, the C, the D, E, and F, was low. What I would like to bring out from this research is that the minimal amount of these extracts, the efficacy of these extracts can be seen when it is given at lower dosage. Looking at this graph, the group D that receive 50 milligram compared to those that receive 100 and 300 milligram was the efficacy of the drug was seen as at 50 milligram per kg. Even looking at this frequency, the frequency for the light and dark pulse, we can see that the frequency for it in the group D was also the increase. So the maximum efficacy of these extracts, aqueous leaf extracts of scopolamine of Cola acuminata, was observed in the treated group D when compared to other treatment group. That is, the efficacy of this extract is seen as at lower dosage. So to conclude my study, this study concludes that aqueous leaf extracts of Cola acuminata leaf have the neuroprotective ability to reverse the effect of scopolamine on memory through enhancing cholinergic function. Also, there is an extension of this study that was carried out by my colleague. They used this same leaf to ameliorate the induced model of dementia in male Wistar rats. But however, the biochemical analysis that was done in my colleague research was to assay for the to check for the oxidative stress and glutathione. That is the antioxidant. Glutathione is for the antioxidant, and the oxidative stress, the biochemical analysis they did was the malonidaldehyde. This is an extension of this study. Thank you, everyone. Once again, I would like to appreciate the organizer of this conference, and it's a great privilege to share my study. Thank you so much.